writing graphing trig functions. We on our, in this class, Andrew's putting his computer away for me, thanks. We're going to be focusing mostly on sine and cosine. After the test, we will take one day and do tangent. It's a weird graph, but it won't be on the test. But we are going to be graphing trig functions today. They will look like this at the end. We're going to have something that looks like this guy. Y equals the sine of x. And we will graph today y equals the cosine of x. So you're going to stop for a minute, and I am going to show you what the heck we're doing. It's weird. You will kind of not hate it. Here's what I want you to imagine. Imagine that that this unit circle is a little Pac-Man, right? So here he is. Here's Pac-Man. Remember? There he is. And I crack him open at his mouth. I just like crack him open, which is so mean. I just crack him open. And I take him and I lay part of his little Pac-Man head right here, right? And I lay the other part of his Pac-Man head right there. And then there's a bunch of Pac-Man, and I crack them all open, and I put more Pac-Man heads right there and more Pac-Man heads right here. Let me show you what I mean by this. Here's kind of what we're doing. Do you see this little weird trippy thing? We're taking this guy, and we're going to spread him out this way. And here's what's cool about that. You can go around the circle a million times, and it just keeps on going and going and going forever, because that's what we're going to do. We're going to take this guy, which is not super usable for us, but we're going to graph him like that. And I'm going to teach you how to do it. It is very easy. Once you get the pattern, you're going to be like, oh my God, these are actually super easy. But in the beginning, they seem a little weird and a little trippy. Okay, so here's the first thing I want you to do. Back on your note page, I want it to look like this. So I did this. We're going to start right here, and you're going to write on your note page y equals sine x, and you're going to put a t-chart over here, and you're going to put a graph over here. Are you guys cool with that? On your paper. Use your little rulers. See, I gave you rulers. Okay, I'm going to get rid of this page. We'll do cosine on the back. We're going to do cosine on the back, but right now we're going to do just sine. Okay. Yes. Yeah, so I want this guy right here, because that's what we're going to graph on, and I want a t-chart. We do 2 t-charts today, and then never again until we do logs, and then we never do them again for the rest of our lives. Amen. For some of you, honest to God. Yay. Okay, so here's what's up. Our goal is to take this terrifying thing, and it is terrifying, and put it in a t-chart. I have some things to tell you. Number one thing is I am lazy, and I do not want to graph stupid numbers that scare me. I don't know what the hell this number is. It's some freaking number. I don't know what it is. I don't want to put it on a graph because it's scary to me. So I am going to stick with numbers that I like. That's the first thing I want to tell you. The second thing I want to tell you is this. And for some of you who did Algebra 2, where Tobin might have shown it, or even Algebra 2 trig, we are pre-calc. We are not going to use degrees at all to graph. And here's why. Degrees aren't real numbers. They seem like real numbers, 90 degrees, 180, but they're out of 360. They're what's called a relative measure, right? They're not a solid number because they just keep going up out of 360. So we are going to be stuck using something that we don't love. But by the end of this little unit, the next 4 days, you're going to be like, I am so good at these. So we are going to, on your little t-chart, you're going to put X here, and it's going to be in radians. And you're not going to freak out on that, and it's going to be fine. And over here is going to be the sign of x. Now, we remember from everything we've done that the sign is the second number. So you're not going to worry about this, but I'm going to show you. These are the guys I care about. I'm highlighting them right now. You don't have to worry about this. I'm just showing you where I'm coming up with this goofy stuff. And these are my x coordinates right here. There they all are. Those are terrifying, and there's way too many of them. So we are going to cut it down to only the ones that we like. Are you ready? Watch what we're going to do. I am gonna get rid of a bunch of ones that I don't like. I'm going to show you what I do like. I like the number 0. Yay for me. And I like this number right here, 0, because it doesn't make me cry. So can we put that on our T-chart, 0, 0. Yay. No tears. The next number that I like, I don't like any of these numbers. They're stupid. I like this number. So I am going to use these two guys right here. Are you ready? We're going to call it pi over 2, and we're going to use 1. Yay. Do I like these ones? No, they're scary. I don't like scary things. So I am going to use pi, because he doesn't scare me, and -1, because he doesn't scare me either. So I'm going to put 1 pi right here, and I'm going to put his partner -1. Oh, is it? Oh, sorry. Thank you. Good call. Good catch. I've been doing this all day. That was the first time I made that mistake. There we go. Oh, there we go. There we go. I knew that. Okay, here we go. We're going to head down this way. We're using this guy, and we're using there's that stupid -1. I knew he'd show up. We're going to go 3 pi over 2, and we're going to use -1. Now, we're almost all the way back to the beginning, and you know what's right here? 2 pi is right there, and 1, 0, I'm going to go ahead and use the 2 pi, and I am going to use the 0 again. Now, we don't just go around once. We're in this class going to go around at least 2 times, sometimes maybe even 3 times or 4 times. And you're going to be like, oh my, is that scary? It's not. Watch what happens here. The next number that's going to go down here, look at this. This is 1 pi over 2, and then 3 pi over 2. Can anyone guess what that guy's going to be? I went 1, 3, 5 pi over 2. Excellent. And you know what he matches with? He matches with this guy right up here. So I'm going to put the 1 right there. Now watch what happens with my whole numbers. 1, 2, 3 pi. Perfect, Val. That was awesome. It's going to match with this guy. I'm going to do another one. I did 1 pi over 2, 3 pi over 2, 5 pi over 2, 7. You with me? Because they're going by odds. 7 pi over 2. And you know what it's going to match with? -1. Now, right now, you're thinking, how am I going to memorize that? You're not. You're not. We're almost done. Let's look at this. We went 1, 2, 3. Let's do one more. Let's put 4 pi, and we're back at 0. If I wanted to, Jackson, I could do 9 pi over 2, right? Because I had 5, 7. I could do 9 pi over 2. It would be super easy, and it would match with this guy right there with that 1. So here's what we're going to do. We're going to take this crazy stuff, and we're going to put it right here. This is the key, and once you get the hang of it, you're going to be like, oh my God, so easy. Are you guys ready? Got your pencils ready? Here we go. We're going to start right here with a 0. This is our radians. Then right here is going to be pi over 2. Then right here is going to be 1 pi. Then right here is going to be 3 pi over 2. Where am I getting these? Right here, right? I'm getting them from right there. You have them on your paper. 2 pi. Then I'm going to go 5 pi over 2. We're going to put those on these so often, you're going to be pros at it. You're going to be like, oh my God, Miss T, these are so easy now. Then 7 pi over 2. Then 4 pi. And then look, there's a 9 pi over 2 just for the heck of it. I don't even have to do it if I don't want to. Now, just so you know, your circle, we can go around it positive. We could also go negative. Would that be okay? It would be. Now, here we go. Big finish. We're going to graph it, and we're going to see the beautiful little pattern, and we will never have to write out the T-chart ever again. Are you ready? So we're going to start way up at the top, 0, 0. Please put a dot at 0, 0, a nice big dot. Then the next thing we did, we went to 1 pi over 2, and it went comma 1. I'm going to put a 1 here, and it went right here. Then I went pi, and it went to 0. Then I went to 3 pi over 2, and it's down here at -1. Are you guys with me? And then it went to 2 pi, which is 0. And then it goes to 1. And then it goes to the middle, which is 0. And then it goes to the bottom, which is 1. And then it goes to the middle, which is 0. And if I wanted to, it would go back up to the top, which is 1. So let me ask you this. If I wanted to graph negative pi over 2, look at my pattern. I went up, and then what would this point be right here? -1. So now we're going to draw it in. You are not 4th grade boys. This is not sharp. This is like a wave. So can you draw it beautifully? And if you want to make this noise, woo, 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 because it's fun, you can, because I do that. Are you ready? Here you go. We're going to go, woo, shut up. Woo, woo. You have just graphed y equals the sine of x. That is him. We're going to talk about some important parts to him. Important part number 1 is his domain. Shh, guys. The domain on this guy, meaning, can I go side to side forever? Yes. He goes on and on and on. His little waves go forever. All real numbers are fair game. But here's what's interesting on this guy. The range is how high you go and how low you go. And he has very, very defined high and low. What's the lowest this dude ever goes? -1. He never goes underneath him. And the highest he goes is +1. And that is the graph. Now, does he go on forever? Yeah, I have little arrows here. But does he keep going down, down, down? No, because he's trapped within that little area. Does that make sense? Is everybody cool with the graph of sine? Now, I need you to write down one important piece. The most important thing I'm going to teach you today is this. Write it down. Sine starts at 0. You're going to see why in a minute. He starts right here at 0, 0. That's sine. We're going to do the whole thing again. on the back of your paper if you like, with cosine, but it's not a whole lot different. Are you ready? Flip your paper over. Here's what I want. I want the chart and I want the graph, but we're going to go much faster this time because we've got the hang of it. So I'm going to highlight what I want. This guy, 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 this guy. Here we go. I'm going to start at 0, 1. I'm going to go to pi over 2, and it goes to 0. I'm going to go to pi, and it goes to -1. I'm going to go to 3 pi over 2, and it goes to 0. I'm going to go to 2 pi, and I'm back to 1. That's one whole rotation. We're going to do it again. We're going to go to 5 pi over 2, and I'm at 0. I'm going to go to 3 pi, and I am over here at -1. I'm going to go to 7 pi over 2, and I'm at 0. I am going to go to 8 pi, or 4 pi rather, and I am back to 1. Here we go. Let's go on here. First thing I want you to do without my help, take your radians and put them on the bottom, please. Here's a hint. We start at 0. We got that. We got pi over 2. Can you fill in the rest of them, please? You want to get used to putting these babies down and getting that pattern familiar. The fractions go by odd numbers. The whole numbers just go up one at a time. Nice and easy. But the other ones are odd numbers because they're halves, right? Oops. I'm going to go ahead and put on 9 pi over 2 just for the fun of it, just so you know it does that. And I'm going to go -1 over here just for the fun of it. Okay. Now, here we go. The very first one is not at 0, 0. Look where he is. He's at 0, 1. He starts up here right at 1. And then he heads down. Now, I am not going to lie to you. When I did your answer key last night, as I did it in my head, I repeated a little slogan in my head over and over. I said, top, middle, bottom, middle. Top, middle, bottom, middle. And here's why. We have a tendency to go top all the way to the bottom and skip the middle guy. And some of you will be like, why did I run out of numbers and it didn't work? Because you're not doing the middle guy. So let's do the pattern. Top, middle, bottom, middle, top, middle, bottom, middle, top, middle. Are you guys cool with that? But if you just go top, bottom, it'll mess you up. So here we go. We're going to draw it in. Whee! There it is. What's different between sine and cosine? Cosine starts at 1. It starts up at the top, right? You know how some roller coasters, you start like in the middle of the ride and then you go up the big hill? And some roller coasters, you walk up the platform and you start at the very top, right? So this is a roller coaster that starts at the top. So you're going to want to write this down. Cosine starts at 1. Starts up at the top and goes down. Does that make sense? What's our domain? Our domain is all real numbers. We can go left and right forever. What's our range? Our highest and lowest. Lowest is -1, highest is 1. Are you good? Okay, now it's time to get a little bit trickier. Are you ready? So the next one I want you to do, either on your paper if you have room, on your whiteboard desk, I don't care. We're ready to do this guy right here. We're going to write this out. We're going to draw this. We are not going to do any more charts. So before we do this problem, I want to talk about something that's coming up that I get excited about because I'm a weirdo. Does anyone know what Mavericks surf competition is? Yeah, what is it?
It's like there's like massive waves happening there.
Yeah, it's one of the few international big wave competitions on the continental United States. It's here in California. You can't actually see it from the shore. It's really hard. And that's because when a storm pattern comes through out at Mavericks, the waves can get to about 50 to 70 feet high. People who surf Mavericks often, like, people die because it's so big and it's so dangerous. The way they call the surf competition is they have a list of names of people who qualified. They call them with 3 days notice because you never know when the conditions are going to be right. And they will literally call them and say, we're running Mavericks in 3 days. So anytime from now till March, if they have the right conditions, they'll run Mavericks. Then they'll call these people out and say, get here. If you're in Thailand, get here. If you're in Australia, get here, and we run it. The reason I'm telling you this is if you've ever tried surfing, I don't know if you know this, you can't really surf on a 1 foot wave. It's too small. It's not going to push your board fast enough. You'll just fall off. If you surf at a 50 foot wave, there's a good chance you'll die. So good luck with that. The best for us as new surfers are like 3 to 4 foot waves. Anything over 4 foot is really over your head and it's a little intimidating. The reason I'm talking about this is because the way they measure waves in real life is called amplitude. And what they do is they take the ocean at flat and they take the top of the wave and they measure this height right here. That's how tall the wave is. You can't go to the top, and that's why Mavericks is so dangerous, because if it's 50 foot high, you also, a lot of them, if you bail out, you hit rock and you die. It's bad, right? Amplitude is how big the waves are. In this problem, the wave that we did was only a 1 foot wave. It went up 1 and down 1 because there was a little hidden 1 right there. Our amplitude was very sad. It was just 1. But today, we're going to do an amplitude of 4. And do you know what that changes? Only one thing. It just means when we graph this baby, instead of going to 1 and -1, it's going to go as high as 4 and as low as -4. So let's graph it super fast. Are you ready? Step 1, label your axis. 0, pi over 2, pi, 3 pi over 2. You're going to get good at this. 5 pi over 2, 3 pi, 7 pi over 2, 4 pi. If you want to do 9 pi over 2 because it's cool, that's awesome, but I need at least 2 rotations. Now, sine always starts at 0. But in this case, our amplitude is 4. It's a bigger wave. So it's not going to just go to 1. It's going to go to 4. And it's going to go back to flat ocean. And it's going to go down to 4. And back to flat ocean. And up to 4. And back to flat ocean. And down to 4. And back to flat ocean. You should, on sine and cosine, end where you started. If you started at 0, after 2 rotations, you should end there. And here we go. You have now just learned how to graph this crazy new equation. Nice and easy. I think she's beautiful. Starts at 0, though. Yeah, does that make sense? Sine starts at 0. Sine starts at 0. Are you cool? Okay, last one, best one, and then I am shutting up. Here we go, our last one. How about y equals negative cosine, negative 2 cosine. So first thing we're going to do, let's label our axis. Everyone label their axis. Nice and easy. 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, and finally 4 pi. Okay, this one's a little bit tricky. Cosine normally starts at 1. But in this case, our amplitude now is 2, but it's tricky. We're not starting at positive 2. Where is this guy starting? Negative 2, because we flipped them upside down. So he's going to start down here at negative 2. Make the same pattern. Low, medium, high, medium, low. Are you with me? So here we go. Low, medium, high, which is at 2, medium, low, medium. I swear to God, say those mediums or you'll forget them. High, medium, low. Am I back to where I started from? I am. And here he goes. Boom, 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 boom. And you've just graphed. Oh, sorry, here he is. Oh, there he is. Are you with me? Are you cool? Domain on this guy, all real numbers. Range on this guy, lowest point, negative 2. Highest point, positive 2. And you've just learned how to graph sine and cosine. Tomorrow, we're going to shift the whole ocean. We're going to do a little global warming and make the whole ocean be 2 feet higher or 2 feet lower. That's tomorrow. I am done. Goodbye.